Greetings, my name is Paul Sisler and this is my midterm presentation for INT 650 Interactive Systems Design. My presentation is based on the book by Donald Norman, The Design of Everyday Things, hereafter referred to through the presentation as DOET. Much of Norman's work involves the advocacy of user-centered design. His books all have the underlying purpose of furthering the field of design, from doors to computers. Norman has taken a controversial stance in saying that the design research community has had little impact in the innovation of products, and that whereas academics can help in refining existing products, it is technologists that accomplish the breakthrough. In the design of everyday things, the emphasis is on people, on how we as human beings interact with the physical objects in the world. This interaction is governed by our biology, psychology, society, and culture. Although DOET covers numerous topics, three have come to stand out as critical. The first, it's not your fault. If there's anything that has caught the popular fancy, it is this simple idea. When people have trouble with something, it isn't their fault, it's the fault of the design. Number two, the power of observation. You will become an acute observer of people, of objects, and of the way they interact. In fact, if there's one single most important part of this book, it is this. Learn to watch, learn to observe. Number three, design principles. DOET contains several important design principles, powerful tools for designers to ensure that their products are understandable and usable. The big six Normanisms: affordances, constraints, visibility, mapping, feedback, and conceptual model. Affordance, a property of a device that enables it to be used. A good designer makes sure that appropriate actions are perceptible and inappropriate ones invisible. The grip of a pistol affords holding. The barrel sight affords aiming. The trigger affords pulling and shooting. Constraint, a property of a device that limits its usage. The surest way to make something easy to use with few errors is to make it impossible to do otherwise. Constrain the choices. The trigger guard of a pistol constrains the number of fingers that can be used to pull the trigger to one, or perhaps two. The physical relationship between the grip and the trigger constrains which finger or fingers can be used to pull the trigger, e.g. not the thumb. The engineering of the trigger constrains the direction it can be moved, backward. Visibility, the degree to which a device's intended use is visible or apparent to the user. The shape of a pistol, its grip, barrel, trigger, makes the way it is intended to be held quite visible. The location and movement of the trigger guard and trigger make the act of pulling the trigger reasonably visible, and the long straight barrel with a hole in one end makes the act of shooting the pistol somewhat, though by no means clearly, visible. Mapping, the relationship between the controls of a device, knobs, switches, levers, buttons, pedals, keys, etc., and what these controls can be used for. Consider the mappings of a pistol. The grip maps to holding the pistol, the barrel sight maps to aiming, the trigger maps to shooting. Feedback. Information a device communicates back to users about actions they have taken. In design, it is important to show the effect of an action. Feedback shows users the effects of their actions. Setting a pistol safety switch to its on or off position might produce an audible feedback click or a palpable drop into a slot. Loading a bullet properly in the breech might produce an audible and palpable snap. Shooting produces an audible report and palpable recoil. Without clear and timely feedback, users can feel lost, clueless, annoyed, unsure how to proceed. Conceptual model, a mental image of how a device works. This short lesson on conceptual models points out that good design is also an act of communication between the designer and the user. There are two types of conceptual models. Design model, the designer's mental image, emerges from designing the device. User's model, the user's mental image emerges from interacting with the device. In general, the closer the user's model is to the design model for a device, the more understandable the device is for the user. The design and user's models for a pistol are very similar. A pistol is a device that shoots bullets at targets. The models diverge to some extent when it comes to details, how to load the bullets, how to use the safety, how to minimize recoil, etc. One has to provide a good conceptual model. Norman says, quote, "The most important part of a successful design is the underlying conceptual model," unquote. Why? Because good conceptual models enable users to mentally simulate operation, to predict effects of their actions, to incorporate existing knowledge, to use metaphors, to feel the object in their gut. Design for understandability and usability. Two fundamental principles of designing successfully for human users. Provide a good conceptual user's model. Make things visible. Get these two right and you're well on your way to designing a usable product. Pity the poor designer. Designing well for all parties concerned is very difficult. Designers want something that's fun and challenging to build. Manufacturers want something that's cheap to build. Retailers want something that's sexy and will attract customers. Repair people want something that can be fixed easily. Safety Commission wants something that can't harm humans. Users want it all. Fun, cheap, sexy, easily fixed. You would need an engineering degree to figure this out. Why do we put up with the frustrations of everyday objects, with objects that we can't figure out how to use, with those neat plastic wrap packages that seem impossible to open? With doors that trap people. This picture shows a short walkway connecting two buildings. There are a set of doors at each end of the walkway. There are two problems with these doors. The first problem is that the handles are designed for pulling rather than pushing, and the second problem is that the two sets of doors work in opposite ways. To pass through the walkway, you must first pull open one set of doors and then push open the second set of doors. Or with hair dryers that have become too confusing to use. Here's a picture showing an attempt to try to plug our hairdryer into an electrical outlet in a hotel room. The outlet is just below the mirror over the sink. You can't plug it in upside down because the mirror is in the way. And you can't plug it in right side up either because the wide prong on the plug won't fit into the narrow slot in the electrical outlet. The electrical outlet is installed upside down. The following slides are going to show impossible objects. Designed by Jacques Perelman, who is French from Marseille and contemporary. He's a painter, sculptor, illustrator, set designer, and fundamentally a self-taught man. He provides delightful examples of everyday things that are deliberately unworkable, outrageous, or otherwise ill-formed. The first impossible object is called the masochist coffee pot. It's possibly the most recognized of Perelman's objects. You may have noticed it on the cover of The Design of Everyday Things. Here we have different types of faucets. The economic faucet, the safety faucet, and the variable faucet. Here are some tools. The electric hammer, the board saw, and the folding travel anvil. Some different types of bicycles. The plow bicycle for farm work, the stamping bicycle for road work, and the snow bicycle. Some health and beauty objects. Earrings that look like ears, a comb for the balding man, and a double toothbrush. Here we have a lateral rocker so that you can rock side to side, a rocking table, and a reverse cuckoo. The blue Impossible Objects link is clickable if you'd like to see more of Perelman's designs. This is obviously an impossible object and totally wrong in design. In conclusion, errors are an unavoidable part of everyday life. Proper design can make a difference in our quality of life. Walk around the world examining the details of design. Realize that even details matter.